his father's financial support in place, Charles Baker began the bewildering task of envisioning the multitude of elements necessary to turn falling water into power.
There were a tremendous number of unknowns. I mean, they didn't really know the geology of the site. They didn't really know how this technology was going to work. It can't be emphasized enough. This was pretty cutting-edge technology.
He had to think about how to put all the pieces together, how to hollow out a cavity that's solid rock, big enough to put generators, turbines. He didn't have a hardware store down the street he could go rely on. He had to get enough crew that were knowledgeable enough to put all this together.
Building the powerhouse at the base of the falls would expose the sensitive machinery to the perpetual mist, causing corrosion over time. Instead, Baker decided to construct the plant underground behind the falls, similar to the one built at Niagara. But unlike Niagara, where the turbines were under the falls and the generators were on top, Snoqualmie's powerhouse would be completely underground, an engineering feat that had never been attempted. The idea proved even more daunting, considering he would need to dig 250 feet down through solid rock. The project's massive scale and remote site required skilled engineers, dozens of motivated laborers, as well as the infrastructure to support it all. With Seattle still recovering from the financial hardships from the Panic of 1893, men were hungry for work. As soon as Baker announced his plans in local papers, 3 men from nearby Falls City hiked to the top of the falls looking for jobs. Baker hired them on the spot and named one as the construction superintendent. Shortly thereafter, Baker had amassed a crew of 35 men. As the winter's snowpack on the Cascades began to melt in March of 1898, the groundwork on Baker's hydroelectric dream began.
Charles was fortunate in that he didn't even have to build a serious railroad spur. We had the Seattle Lakeshore and Eastern Railroad coming right by the lip of the falls.
None of the major equipment was made in this part of the world. All of that had to be brought across country by rail and brought to the site by rail.
Baker's men laid down track, connecting the Seattle Lakeshore and Eastern Railroad to the construction site, and erected a 5-story hoisting tower that would lift the immense cargo from the arriving train cars. With the means now in place to receive supplies, equipment, and even crew, houses were then built on-site for Baker and his superintendent, while a dormitory was constructed for the crew. The town of Snoqualmie was a mile away, and although employees and their families could shop and go to school there, the men needed to be on hand at all times. Married men and their families lived in 4 cottages, the largest for the superintendent. Single men bunked in a 10-room dormitory where they took their meals. A guest house, also called the President's House, sat highest of all the structures, with its sweeping view of the power plant buildings and the top of the falls. The cottages rented anywhere from $7 to $12 a month. While lodging was constructed, supplies were ordered. Baker shipped in 20 tons of dynamite, an air compressor system, hard rock drills, and 2 massive steam engines to power the operation.
They had to build their own steam plant on the original riverbank in order to run their hydraulic drills, in order to run the hoist that would be used to pull the rock out of the cavity.
Baker then hired the Puget Sound Bridge Company to build a 15-foot cofferdam to keep the river at bay from where they would begin blasting away into the bedrock. Finally, on April 18, 1898, the drilling began. Using steam-powered drills, 10 at a time, the crew bored down into the volcanic basalt. Mining laborers, known as powder monkeys, tamped the dynamite into the holes and touched off the charges. For weeks on end, day and night, the echoes of the dynamite blasts could be heard for miles, as the crew slowly carved out a shaft that measured 10 by 28 feet.
This was not a mining operation where you could get in and go away and you didn't have to think about the site anymore. This is a place that still had to be watertight and stable for the long-term future after it was done.
After the smoke and dust cleared from each blast, workers hoisted out the rock. The large boulders were then crushed and deposited along the riverbank to be used as the base for the transformer house and support shops. On and on the blasting and clearing continued. When the shaft reached a depth of 250 feet, laborers pointed their drills northwest and began to carve what Baker called the Great Subterranean Chamber that would house the water wheels, generators, and control system.
They hollow out the cavity to give enough room to situate the generating equipment.
The cavity is 200 feet long. That's the length of 2 basketball courts placed end to end, 40 feet wide, 25 feet tall.
That is pretty incredible. It's not sand, it's not dirt. This is solid rock.
As the cavity neared completion, part of the crew set out to drill another 400-foot tunnel for the tail race, the channel that would return water to the river. A 700-step stairway was built down to the base of the falls, where another crew of men drilled from the opposite side.